Alright, let's talk about ospf. We're going to talk about the characteristics of ospf, single area ospf for version 2 and version 3. I'm really going to focus on version 3 because that's what you need to know. Alright, the difference between version 2 and version 3. Version 2 was made in 1998 and version 3 was made in 89. The reason being is version 2 focused on IPv4 addressing only. Version 3 included IPv6. The features of ospf, it's classless, meaning what? We can do VLSM, right? It's efficient, has fast convergence, scalable, and secure. Similar to the CDP neighbors command, where you can say show CDP neighbor, you can show IP ospf neighbor. Same thing. All you're doing is looking at that its routing table. Does that make sense? That's what we call an adjacency database. Now we also have a link state database, which is the database that gives the network topology. That's going to be your show ospf or show IP ospf, if I can talk tonight, database. And then the forwarding database is just the route, because it's the routing table. That's how you forward things, right? The components of an ospf, we have the hello packets like we talked a little bit about last week with EIGRP. It'll have a data description packets, link state request up and update, and then the acknowledgement. All right? Y'all remember those from last week? What was the difference between these and EIGRP? This one carries the database description, where the other one you query the database. All right? If an ospf neighbor is present, the router attempts to establish an adjacency with them. For example, Josh and Casey are sitting next to each other. They're neighbors. So they're going to initiate communication between them all semester because they sit next to each other in class. Whereas it would be harder for Jordan and Nick to do it. Why? Because they're spaced out. Does that make sense? Link state operation. The routers exchange the link state adjacencies by giving them each other the phone number, their email address, things like that, right? If I assigned you in a group, what's the first thing you're going to do? Get the contact information with everyone else in your group, right? You all start a sheet of paper, piece of paper, you write your name down on it, pass it around until you get it back, right? Routers have a tendency to flood those LSAs to everyone else. Don't be in contact with the router. They will flood you. They'll call you all day long. It's that annoying boyfriend or girlfriend that never will leave you alone, right? All right. Let's talk a little bit about link state operation. Well, everything that's coming off of this link state here is going to go into what we call a topology table, or the link state database, right? Y'all with me? It's going to be building a picture of this topology by getting these LSAs from these three routers. Between getting the information from these three, it knows how to get over to here. Does that make sense? For example, it looks at router 1. Router 1 has a shortest path to router 2, to router 3, and to router 4, right? Router 2, router 3, and off of router 3, it also has this one, which is the 7 network. And if I need to get to 4, to get down here to the 8, I can go to here to down. Or I can go to R1 to R2 if I need to go to the 9 network, which is over here, right? If I'm going to 5 network, it's up here. What if I want to go to the 10 network? How do I get to the 10 network? I come here to go down here to come over, right? You know, make sense? The 11. Go here to here to here to here. Well, why can't I come from router 1 to router 2 and over? The longer distance. We have a 20, right? It takes 20 to get here, but it only takes 15 to get here if I go through router 3. So which one am I going to go through? Exactly. And that's how it builds that topology database so it knows which way is the best route to go. Area 0 is what we call our backbone, okay? Our backbone infrastructure. So you'll have IP ospf area 0. Similar to the autonomous number, but it gives the idea of what it is. Now we have a multi-area where you have router 2 functions in area 0 and area 51. So it's out in Nevada, right? Hint, hint, hint. Laughs. Okay, never mind. If you're a router that's on there, we call it an ABR, which is an area border router. That means it has 2 areas that converge in that router that it can talk to. It's that border of those two areas. That makes sense, right? What is my area 1, area 0 ABR? R1, very good. What's router 2? It's the ABR for area 51 and area 0, right? Routers in area 0 do not need to run the SPF algorithm. Why? Because it automatically sees them already. Let's talk a little bit about the ospf IPv4 header. What did I say data link frame header was? What is data link? What's on the data link layer? The MAC address, right? It's that physical address. What's IP packet header? What's in there? It's the source and the destination IP address, right? What is the ospf packet header? It says that the area, and then it's ospf. What type is it? Is it version 3? Is it version 2? Okay. And then the ospf packet type specific database. Is it a 01, 02, 03, 04, 05? It says what kind of traffic that is. Does that make sense to you? So if we did a Wireshark and we were looking at ospf, do you think you'd be able to figure that out by expanding down the packet, where it came from, where it's going to, and what kind of traffic it was? Again, 1 is the hello, 2 is the database description, 3 is the link state request, where I'm requesting what is the status or the state of the system. Update is what would be supplied, and then I acknowledge it back. Yes, Marlon?
So I'm just trying to put this in the reality. Like if you say OSPF, you're looking at Wireshark, like when you see protocols, you'll see like TCP, IP, DNS, ARP, will you see OSPF?
No.
Will you see within the packet?
You'll see it within the packet.
It's not a protocol.
Okay. You could, it's not really a protocol, it is a packet. Okay, so if you're using packet sniffers, you will see it. But it's not going to be a protocol.
That the same field.
It will be. They term it protocol, but it's not always protocol. It's a type of packet. The OSPF1 type packet is a hello packet. It discovers the OSPF neighbors and establishes that adjacency. In that first hello packet, it establishes who my DR and my BDR are. What is a DR? It's a designated router. What does that mean? That's the one that says where everything goes, right? And it also elects a BDR, backup designated router. In case the DR gets cut off, you have another DR. Okay? This is what you would see if you were to look at that packet. And of course, you'd have packet information up here, which would be your MAC address and IP address of where it's going. OSPF hello packets are transmitted to the 224.0.0.5. So if you want to look at OSPF only, look at 224.0.0.5 in your network. Or FF02::5. Okay? I'm not going to talk about the updates. You kind of got that last week a little bit, right? Enabler adjacency. Router 1 is down. It goes to initialization. Sends out, says, I'm 172.16.5.1. Is anyone else on this link? Does multicast to the 224.0.0.5. Router 2 sees it, sends it back, hello, I'm 172.16.5.2. Here's my neighbor list. It sends it unicast back to 172.16.5.1. What's the difference between a multicast and unicast? Exactly. It's the multi-sent email versus a broadcast email, which we all call spam, or a singular email, which is your unicast. Okay, we have a two-way state. Router 1 takes the neighbor list that came from router 2, and then it understands it. Then R1 will just share its default priority of 1 in the second router, highest router ID. In this case, it's going to be the backup domain router. Why? Because router 2 has a default priority of 1, and it's the highest router ID. Did everyone catch that? How would you like to have one like this? The number of adjacencies is n to the n minus 1 divided by 2. So we have what? 6 devices? No, we don't. We have 5. Because a switch doesn't have a routing table. Ha, ha, ha. Caught you, right? So 5 minus 1 is what? 4. What's 5 times 4? 20. Now divide that by 10. Or divide it by 2. 10. Does that make sense? Tells you how many adjacencies there are. Calculate them. Is it right? Huh? I'm not going to talk about synchronizing it. How do we do IPv4 router, ospf? You learned it with router RIP and router EIGRP, right? So what do you think ospf is going to be any different? No. Router ospf and what is 10? What does the 10 stand for?
Not like it's a logical name.
The autonomous number.
Does this help? It is an autonomous system number. You define an area inside of it. So router ospf 10, the networks are 172.16.1, 16.3, and 192.168.10.4 with their wildcard mask all come off of area 0. Make sense? Passive interface, what did I tell you all about passive interface? You only want those that need to be passive. And here's how you do it. You go in the router ospf 10, passive dash interface, tell me what interface it is, and say end. It assigns passive interface to it. Alright? The reference bandwidth for any of the fast Ethernet or gigabit Ethernet are going to be 1. If it's just Ethernet, it'll be 10. Then you go down from there. All right? We talked about the accumulated cost or the route metric. Remember we did that formula last week a little bit. We can adjust it if we want to. Instead of 10, we can do 100,000, 10,000. We can set it to whatever we want it to. So if we see the bandwidth of 1544, what kind of connection was that? Serial, very good. What about 64K bit a second?
Say 64.
64K. What is that going to be? Again, that's going to be on your serial. What about 1544? It's your T1 lines. But it's on serial. Show IP ospf neighbor, same thing. Depending on what your neighbor is, what the adjacency is, it'll bring it in and show you. Is any questions on that? IP protocols, we talked a little bit about that last week. I'm not going to go back over that. What's the difference between version 2 and version 3? IPv6 is in what version? Version 3. Okay. Similarities between the two. They're both link state. They're both SPF. They both go by cost. They both have the same type of packets, neighbor discovery. They both elect a designated router, backup designated router. The router ID will always be a 32-bit address, which is an IPv4 address. And the areas are a two-level hierarchy. What are the differences? OSPv3 is IPv6 prefix and local link address. And instead of just advertising networks, you use the network command over here. You use the IPv6 OSPF process ID area ID. Where you had the autonomous system number in EIGRP, the 10 was relating to our process ID. The area is the locality of where that interface is on what area it's in. Okay? If it's trying to find the OSPF, it's going to use the FF02:5 address to send it out. FF026 will be the multicast address that you send out the DR and BDR elections on. You know what I say about Cisco equipment that's on OSPF? They have better electoral representation than we do. No disputes, no hanging chads, right? All right, y'all remember how to do descriptions on your interfaces, right? All you got to do is go into the interface, type in description, and say what the description is, and then give it an IPv6 address. Remember, anytime you're doing IPv6, you have to do the unicast routing. Okay. You turn them on, no shut, go to the next serial, do the same thing, give it a description, address, clock rate, shut it down, or no shut. Why is it important on serial 000 to have a clock rate? Why not 0001? Anyone have an idea why we put a clock rate on it? What kind of cable do we put a clock rate on? DCE. C meaning clock rate. Okay. Link local addresses are going to be your FE80 : 32F7 : DFF : FEA3 : DA0. Now, that's to this particular thing, okay? It's not your normal link local address. All right. Your normal link local is going to be FE80 : 1. FE80 is 127.
That's 127.
Be 127.0.0.1. Same thing. It's your loopback address. Okay? I'm not going to worry about that troubleshooting process. To put in router ID, remember, it's going to be your IPv4 type address. 1111122223333. Alright. Let's see here. Configuring the OPv3. Again, IPv6 OSPF. 10 being the process ID, area whatever it is. That's all you type in. Pretty simple, right? If you want to see the neighbors, it's show IPv6 ospf neighbor. You want to look at the protocols, it's show IPv6 protocols. Pretty simple. What's the difference for IPv4? It's just show IP protocols. Show IP ospf neighbor. Y'all catching the difference now? The only difference between a 4 and a 6 is you put v6 after IP. That's it. Don't let it confuse you. All right. Let's go to... I'm not going to let you troubleshoot it. We don't really need to, I don't think. Let me look through real quick. Static routing, y'all know all that. I'm started talking about the election process, secure routing updates. We don't need that one. Let's talk about multi-area OSPF. We're going to explain why multi-area OSPF is used, what LSAs are again, what neighbor adjacency is. Okay. Multi-area. Single area are used for smaller networks. Okay. But if an area gets too big, you got to start looking at how do you. Things aren't going to get summarized the way they should be. Your database can get screwed up. SPF can get really messed up with calculations. So let's talk a little bit about multi-area OSPF. All right, now we're throwing in a new thing called the backbone, right? Y'all heard that term many times. Everyone must connect through the backbone area in order to get to the different things. So if we're going to do OSPF on campus, we could say each one of the division buildings are going to have their own separate area. Running between all of them, interconnected, would be our backbone. Does that make sense? Backbone's our transit area. It's going to be our usually the step up higher than the network you're already on. So if you're on 100 megabit, you're on a gig backbone. Does that make sense? The regular OSPF area connects the users and the resources to that backbone. Pretty simple. We're just adding that layer up here. Does that make sense? Where R1 and R2 could connect directly to the internet. R1, R2, everything in area 0 would be a backbone router. Does that make sense? Area border routers, we already talked about them. They shadow between the two borders. Autonomous system boundary routers, what would that be? That's everything that's behind that router that's going to the internet. Everything behind that, that's going to be our ASBR. All right. So if we have an ASBR in area 1, ABR between 1 and 0, and ABR between 0 and 2, everything that's connected in area 1 will go to ABR 1, right? Everything in area 0 can go to either 1 or 2. And everything in area 2 will eventually come back to ABR 2. ABR 2, ABR 1 all connect to go to ASBR, which then goes out to the internet. Does that make sense? I'm not going to cover LSAs. All that is a link state algorithm going back and forth saying who's who. If you have an O, that's a router type 1 and the network type 2 LSA that describes what's in that area. For example, we have the O's right here, right? You see the bunch of O's? If we have an OIA, that's our summary routes for the network. OE1 or OE2, we don't have an OE1, but an OE2 are external links. Does that make sense? Huh? Yeah, it is the top one. O star E2. Here's the IPv6 version of it. Okay? Same thing as that IPv4, you have the IPv6 addresses. So, what does 110 mean? .110 identifies this as OSPF traffic. 0 is direct connect. Everything else is OSPF. Alright? I'm not going to talk about calculations. Implementing multi-area OSPF. We're going to define the OSPF parameters. We're going to configure OSPF, and we're going to verify it. So how do we configure it? Simple. Router, OSPF, and then the process ID. So 10. Router-ID, we're identifying this router as being this IP address of 1111. The 3 networks on there. So area 1 has the 1011 and the 1012, right? If the dot ones are on that network, so we go 10111 and 10121 0000 because that's a specific IP address. They're assigned to area 1. The network 192.168.10.1, and we could also do 192.168.10.2. Wait a minute, 192.168.10. They got that screwed up. It should be 192.168.1.1 and 192.168.1 or 2.1. Could be areas 0. No, hang on. No. I got what they're saying now. I'm looking at the wrong thing. Right here. This is in area 0. We're looking at R1. To identify these 3 networks. Coming off of here, it tells you what area they're in. Does that make sense? If I want to do gigabit, if I wanted to do, I have got my logical link address of the FE80 ones, which would be the loop back here, 2s and 3s. Does that make sense? That's all that is. So we're on router 1. We're configuring OSPF 10. We're going to go to the gigabit interface. We're going to assign it what area? Where's this area? Area 1. What is this area? Do what? 0. This serial 000 is on area 0, right? Does that make sense for you to visually see what I'm talking about? Okay. R1 is going to forward a summary LSA to the core router. How does it get there? C1 then would in turn forward the... Let's see. R1 is going to forward it to C1. He's going to return it to 2 and 3. Those go to R2A and R3A, and then they come back up. Okay? Same idea. That's how you elect an ABR. The autonomous system BR. Which one's the ASBR in here? R2. Good job. Why? This is going over here to the IGRP area, and that's the internet, right? What about inter-area routing? What's my ABRs? What are my ABRs? 1 and 3. Why are they 1 and 3? Because they're the ones that just break the 2 different areas, right? Alright, I'm not going to go through subnetting because that will just throw your mind off. When you're on the configuration and you type in this mask, It comes in and it says that's going to be a summary default route. Why? 10100/22 is a summary. It's going to get passed from router 1 to router 3. ospf IA. What does the IA stand for? Enter area. R1 and R3 see the same area, right? So if I wanted to go to the 10100/22, I need to know that I need to go out the via 192.168.10.5. It will connect up to router 1 that will or router 3, whichever router 2, which one it is, will forward it back over to router 1. Again, it's all the same commands. Show IP OSPF neighbor. Okay? Or show IP protocols. The only difference is you substitute instead of IP, it's IPv6. That's it. So is IPv6 in here really hard? All you have to do is just substitute IP for IPv6. Same thing, guys. It's not that difficult. It looks crazy because you have all these weird hexadecimal numbers, but it's still the same. So I'm not going to go through that because we've already seen that multiple times. It's the same thing for the multi-layer, multi-area. What does the I stand for? It's the internal, right? So if I'm looking at Cafe 3, where's Cafe 3? Right here. Cafe 3, and it's going to go out via this 2 right here, up to the 2. If I need to get here, I've got to come in through this link local of FE80. Alright? Josh, you okay? Okay. Any questions? Are you ready for your 70 question multi-choice?